Some properties of vectors. Two vectors are equal if they're the same. It's a good property. If they have the same magnitude and same direction. So it's not enough just to be the same but in opposite directions. But if they've got the same length, in other words, same magnitude, same length, and same direction, they don't have to start at the same spot. So the neat thing about some of the math that we do with vectors is that we can do math with vectors, it doesn't matter where they are and where their starting points are. And so we can solve some more complicated questions because we're not restricted to where they're started.
So would like a vector from 0 to 6, 3 be the same as a vector from 6, 3 to 0?
From 0 to 3, so are you talking about 0, 0? And then 6, 3, okay. That would be this vector in this direction.
Would it be the same as the vector in the opposite direction?
No, that would be called an opposite vector. So the direction has to be both the same direction and same magnitude. And if you multiply a vector by a scalar, so you could have a vector v and double it, it would still be in the same direction as what you started with. It would be parallel. It would just be longer. And if you multiply a vector by a negative, then it would go in the opposite direction. And when you have a vector whose length is 1, we call it a unit vector. So we have our standard unit vectors. If we're talking in two-dimensional space, these would be our standard unit vectors, and we like to use letters I and J. So I would just be 1 unit in the x direction, and J would be 1 unit in the y direction. So you can always write any other vector as a combination of unit vectors. So OA, which went to 6, 3, can be written as 6 of I plus 3 of J. Because if we wrote this out, I was 1, 0, and J was 0, 1. And if you multiplied that 6 through, and in this sense, the vectors are acting very much like matrices, right? We're adding matrices and multiplying a matrix by a scalar. Yes?
I looks like they're dealing with complex numbers.
Yeah, and it's not a complex number because it's bolded. So that's the difference. So we'll end with this. Take each of these vectors and write them in terms of I and J.
Sorry for the interruption.
Did you get 3I plus 2J for the first one? Because it would start here, and you need to go 3 to the right and 2 up. For B, negative I plus 3J. Two I minus 4J. Minus 3I minus 5J?